We're going to work through example 4 from notes 4.1, days 2 and 3. And in this example, we're going to analyze rational functions to determine the coordinates for wholes. This first paragraph that we have is trying to distinguish when we have a vertical asymptote versus a whole for rational function. When we have a 0 in the denominator, then we would either have a vertical asymptote or a whole. So here this paragraph says we're given a rational function, f of x, which is a ratio of polynomial functions, n of x in the numerator and d of x in the denominator. And we're going to have z be a 0 of both the numerator and the denominator, which means we're going to have a factor of the form x minus z in both the numerator and the denominator. So to determine if we have a whole versus a vertical asymptote, we're going to look at the multiplicity of the zeros in the numerator and then in the denominator. So we're going to look at those factors of the form x minus z. So if the multiplicity of z as a 0 in the numerator is greater than or equal to its multiplicity as a 0 in the denominator, then we're going to have a whole. So that might be something like x minus 2 cubed over x minus 2 to the first. In this case, we're going to have a whole because the multiplicity of the 0, 2 in the numerator is 3, and in the denominator it's only 1. So we cannot cancel out, so we can cancel out the factor x minus 2 from the denominator, and that in that case, we will have a whole. Otherwise, the graph is going to have a vertical asymptote. So if the multiplicity is greater in the denominator than in the numerator, so something like x minus 1 squared over x minus 1 cubed, in this case, we're going to have a vertical asymptote at x equals 1 because we cannot cancel out that factor of x minus 1 from the denominator. So let's go ahead and do the analysis. When we're analyzing rational functions, we're going to factor the numerator and the denominator. So in letter A, x squared minus 9 is a difference of squares, which I can factor as x plus 3 times x minus 3. And now we're going to determine whether we have vertical asymptotes or wholes at various values. So first, let's try to do vertical asymptotes. I'm going to write VA for vertical asymptote. And for vertical asymptotes, I'm looking for when the denominator is 0, but the numerator is not equal to 0. That's in the simplest case when the multiplicities are the same. Or technically, I really want to find when the 0 in the denominator has multiplicity greater than or equal to that 0 in the numerator, which means I cannot cancel out that factor. Here, I'm going to have x minus 3 is a 0 of the denominator, but not of 0 of the numerator. So I'm going to have a vertical asymptote. I'm looking at this factor now, which isn't common. I'm going to have a vertical asymptote at x equals 3, and its multiplicity is going to be odd because that factor occurs just once. Next, we're going to look to see if we have any wholes. So to find a whole, we're going to look for common factors in the numerator and the denominator. So we're looking for common factors in numerator and denominator, and more specifically, the multiplicity of the common factor in the numerator has to be greater than or equal to the multiplicity of that factor in the denominator, which means that we can cancel the factor out of the denominator. That's the key thing. So in this case, we have a common factor at x plus 3 here. So x plus 3 in the numerator and the denominator, both with multiplicities of 1, which means we're going to have a whole with an x value of negative 3. But what's the y value of this factor? To find what's the y value of this whole? We can't just substitute negative 3 back into our original function. If we did that, we would get 0 over 0. So instead, we need to substitute negative 3 into the simplified function. And that's the key to finding the y value. So if we simplify this, the simplified function would be 1 over x minus 3, where x is not equal to negative 3. All right, so we're going to find the y value, we're going to put negative 3 into the simplified expression function, which is 1 over x minus 3. So 1 over negative 3 minus 3, which is 1 over negative 6, which means we are going to have a whole at negative 3, negative 1/6. All right, so we found our vertical asymptote and our whole. So the vertical asymptote, remember, was at x equals 3 with odd multiplicity, and our whole is at negative 3, negative 1/6. I'm running out of room here, so I am actually going to erase some of this example, and then I'll use that space for example B. Okay, so back to example B, we're going to analyze the rational function shown here. Okay, I'll erase just a tad more, sorry about that. Okay, so first thing we want to do when we're analyzing a rational function is factor. So let's factor the numerator here. So this is going to be x minus 2 times x plus 1 over x minus 2. When we're trying to find vertical asymptotes, we're going to look for zeros in the denominator, but that are not zeros in the numerator, or zeros in the denominator with greater multiplicity than those zeros in the numerator. So in this case, so we want the denominator 0, but the numerator is not equal to 0. So for this function, we have no vertical asymptote. It's none, because the only factor in the denominator is x minus 2, which is also a factor of the numerator. Now let's go ahead and find wholes. So for wholes, you're going to be looking for common factors, right? Common factors in numerator and denominator that we can cancel out of the denominator. So in this case, x minus 2 is a common factor in the numerator and the denominator. It has equal multiplicity in the numerator and denominator, which means we're going to have a whole with an x value of 2. If I simplify this function, I would cancel out x minus 2 in both the numerator and the denominator, leaving me with x plus 1, where x is not equal to 2. So to find the y value of a whole, I need to use the simplified expression. That's the key, the simplified expression. And if you do not use the simplified function, you'll get 0 over 0. So you'll know you did something wrong. So to find the y value, the simplified function is x plus 1, and we're going to put 2 into that function. So it'll be 2 plus 1. So the y value is going to be 3, which means we have a whole at the order pair 2, 3.